Well, thank you all for coming to the 2018 State of the Bay Symposium. For those of you who don't know, I'm Professor Chris Gobler, Stony Brook University School of Marine and Atmospheric Sciences. And also, if you didn't know, let's keep that back door, one of the back doors propped open just in case people want to, the second one, if people want to float in and out without having to, okay. So this is the fourth and final of our spring lecture series. So those of you who may not know, we have these lectures for every semester, fall and spring, so this is the last one. I do appreciate you all coming. And as you can see, the title of this year's State of the Bays Symposium is Clean Water is Life. And maybe that'll become more apparent as the presentation goes on. And essentially, I've got three major components I'll be covering, mainly focusing on water quality impairment and things we're doing to improve water quality. But I want to start by acknowledging the people in my lab group. I call them the boots on the ground, the fins in the water, and the ones who really get everything done. Hopefully you got a chance to interact with them and see their posters. So please join me in giving them a round of applause. They're really the ones who make this all come together. And it's really an honor for me to be able to work with them. And it's one of the most exciting things I do is to be able to see what they're up to and the results they're finding and to work with all of them. And so, and they'll be back at their posters at the end of the symposium. So if you heard something you want to learn a little bit more about, go back and talk to them some more. And so it's been an exciting year for me on several fronts. As you may know, we had a visit from the governor last May. And I've had a few interactions with him since. And so I've taken some slides from him because I really think they summarize a lot of what we're doing here in my lab group. So you can see, a big thing of what we're doing is rising to the challenge to protect our water and our resources in our coastal estuaries. And also, we know that the health of our people and our economy rely on a protected and healthy environment. And conversely, that if we don't address pollution in our water, the consequences are devastating, not just on its beauty, but also, it ends up being something that affects all of us. And on that front, of course, we all know, this is a slide I show all the time, we live in a watershed here in Long Island, and of course that affects our bays. You can see anything going on the land is going to then infiltrate and become part of our groundwater. But beyond, and that groundwater, of course, discharged in our coastal waters. But beyond that, what we're coming to realize more and more is that it's not just affecting our bays, but of course, it's affecting our drinking water. And so I'm just going to actually start out with just a couple of examples of this that are highly concerning. So, for example, a chemical like 1,4-dioxane, which is known as a likely carcinogen. And you can see anywhere in the red is an area on Long Island where the drinking water supply is at a level above the US EPA advisory level. And this is of great concern because this is a compound that water suppliers are not really sure how best to treat. So it's very concerning. And I'll point out that I co-direct with Dr. Hal Walker the New York State Center for Clean Water Technology. And one of the things we're doing is trying to come up with and pilot test some new treatments known as advanced oxidation processes to remove 1,4-dioxane. But that's just one of the big issues. In fact, just 2 years ago, that was the only really big issue for drinking water. In fact, the New York State Department of Health, when they said, what should the Center for Clean Water Technology work on when it came to drinking water, they said, oh, definitely 1,4-dioxane. That's our biggest concern right now. And here we are only 2 years later, and now there's another emerging concern that you may be aware of, perfluoronated compounds, PFCs, that are showing up more and more in drinking water supplies. And as you can see, there's a cluster here on the east end that's of really large concern. In the western part of Long Island, when something like that gets into drinking water, thankfully, almost everyone gets their water from a public supplier. That's a lot easier to deal with. You have a public supplier giving water to 100,000 people, 200,000 people, they can treat that water. But when we're dealing with things out here, we're looking at people with private wells who, in each individual well coming up contaminated. And I bring this up on two fronts. One, you can see we're in Southampton, and we're surrounded by places, for example, Wainscott, Hampton Bays, East Quogue, West Hampton, Islip, and I think also in Yaphank. But I'll point out, in East Quogue, that's the highest detection ever recorded. And you can see what the advisory level is and what they're finding. And in fact, I know this very well, because actually this is only 500 feet from my private well. And so my new reality is I'm on bottled water. And hopefully my drinking water is clean. I actually don't know, and I'll find out shortly. But it's become very real to me individually that contamination of water, be it from nitrogen or some other contaminants, is a real issue, and that even if it's not necessarily your backyard, whatever's getting done is going to be affecting both our drinking water and our coastal waters. And moving on to our coastal waters, I'm going to start now by reviewing what we saw in 2017. Here's our annual map of water quality. For those of you who are not familiar with it, this map comprises data collected between May and Labor Day, so early May through Labor Day. So really, in the end, it ends up being only about 4 months or so of data. And in just 4 months, you can see, as has been the case for year after year, there's really not a coastal water body on Long Island that isn't affected either by hypoxia or by harmful algal blooms. And we know that a lot of what's driving that is changes in our population here on Long Island, and that's of course driving drinking water trends as well. The enormous growth we've had, for example, in Suffolk County, which is now more populated than Manhattan, more populated than Nassau County, more populated than Staten Island, more populated than the Bronx. And as a consequence, with more and more people, rising levels of nitrogen. And the studies are in. Most of us probably know. There's been multiple studies over the last decade that have shown that most of the nitrogen in the groundwater across Long Island is coming from wastewater. Some fraction of it does come from fertilizer, but in study after study, wastewater has come up as the biggest source of nitrogen, which, stepping back, shouldn't be a surprise. We live in one of the most populated regions, both with regards to numbers and also population density. And I don't know how well you can see all this, but this is part of Suffolk County's sub-watershed study, where they're modeling the concentrations of nitrogen in groundwater all across Suffolk County. And I simply want to just point out, if you see any area that's in red, that's an area that's above the EPA threshold for nitrate in groundwater. So any area in red is an area that really can't be used, just for purposes of nitrogen. And that doesn't consider other things. But we've really, between the wastewater and the fertilizer, have hit levels that are untenable in many locations. And just to give the global perspective, we're not alone. There's a Sustainability Institute in Europe that puts out periodic studies. This is the most recent one. They call this the Safe Operating Space for Humanity, where they consider on a global basis for planet Earth, what are the stressors we should be most concerned with. And you can see what they put out here: ozone, ocean acidification, climate, pollution, particle pollution, fresh water use, phosphorus, deforestation, biodiversity. You can see nitrogen is right there at the top, number 2 behind biodiversity loss, and far above many other things that we might grab our attention. On a local level, research in my lab group over the last decade, and actually across the globe, has shown that high levels of nitrogen lead to harmful algal blooms that are either more intense and or more toxic. And on the toxic front, I'm going to start right now by talking about Alexandrium. You may or may not be a chemist, but if you put your focus here, this is the reason we worry about Alexandrium, which is a dinoflagellate, a phytoplankton, and there's saxitoxin. And if you look at that compound, you can see all the ends, those are nitrogen atoms. And so what scientists, myself and others globally have learned in the last decade is that with all of the nitrogen-rich algal toxins, this is just one of them, there's others as well, the more nitrogen a cell gets, the more toxin it can make. And it works in reverse. If you starve it of nitrogen, it becomes less toxic. So we're worried not just about the blooms being more intense, but also their toxins. And again, this organism causes paralytic shellfish poisoning, which of course is of grave concern. Every year globally, people die from paralytic shellfish poisoning, and even in the United States and Alaska in the last decade, there have been fatalities associated with intense PSP. We've detected this organism all throughout Long Island, and anywhere you see a dot in the red, is an area that's high enough to make shellfish toxic. But in 2017, well, before I get to 2017, I'll also just point out research in the past have shown definitively, one, that more nitrogen intensifies these blooms, they grow more, and like I just said, more nitrogen makes them more toxic. And then the other thing I'll point out, in a paper we published last year, we were able to show definitively that the die-off of terrapin turtles, where hundreds of terrapin turtles died in Flanders Bay in 2015, was traced back to those turtles consuming rib mussels. So the rib mussels had an order of magnitude more saxitoxin than the federal limit for human consumption. The diamondback terrapin turtles had rib mussel DNA in their gut tracts. We did that via high throughput sequencing, and the level of toxicity was so high that the turtles would have had to only eat between 1 and 3 mussels to receive a lethal dose, which led to the multi-investigator team of scientists to conclude that it was saxitoxin that was responsible for that particular event. 2017 was actually somewhat unprecedented with regards to PSP. We had the western part of Shinnecock Bay closed to shellfishing for the 4th time in 6 years. We had James Creek closed. This is on the North Fork around Great Peconic Bay, closed for the 3rd consecutive year. And a concern here is that we only started looking in 2015. Suffolk County collaborated with my lab and said, you know what, let's cast a broader net. Let's look real careful in all these different little creeks all around. And they pointed this one out, and together we looked, we said, you know, you better check the mussels. The cell densities are really high. And sure enough, toxicity in the shellfish there, and it's been closed every year since. Not consistently, these are seasonal events. Just north of there, the Mattatuck Inlet was closed in 2017 for the first time in 5 years. And then 2 locations that have never been closed before, maybe 3, it depends how you want to count it, but Deep Hole Creek, Halls Creek, and then also this area of Great Peconic Bay, which means that there were, again, depending how you count it, an unprecedented 5 to 6 locations closed due to PSP in 2017. So the extent, therefore, being more widespread than ever before. And within Mattatuck, I'll just point out, if you're not familiar with that area, this is an area that actually, for me, just looking at it, is of grave concern. So what I just showed you is 1, 2, 3, 4 different water bodies contaminated with PSP, as well as this area closed, and then a freshwater body within a stone's throw that was contaminated with microcystin and declared unfit for swimming by the DEC just a few weeks later, and in that state for most of the summer. So you can see here's an area that is really in need of attention, and you can look at the landscape and just see that, you know, if we're thinking about nitrogen, there are lots of homes here as well as agriculture, and of course, as if I hadn't pointed out already, and I think I didn't, all these homes not connected to sewage treatment plants, but rather with conventional septic systems that convey most of their nitrogen directly to the groundwater. Moving on to other harmful algal blooms, brown tide blooms are a chronic problem on the south shore of Long Island. Looking back to the course of history, it's interesting to note that in the Peconics, we only actually had 4 of these events. But unfortunately, they were intense enough to be responsible for the collapse of the bay scallop fishery that to date hasn't recovered. New to my lab is Michael Dole. Raise your hand, Mike. His name will probably come up multiple times today, but he put together this new plot for the occurrence, or for the landings of hard clams in Great South Bay. It's new because he took it all the way out to 2016. And so what you see is this initial drop was not due to brown tide, happened before that, 5 years before. But it declined. But when the brown tide started, they were still landing over 150,000 bushels of clams a year. But continuous brown tides have prevented the ability of this system to recover, and I'll show more of that momentarily. And of course, we know how brown tides also affect eelgrass. So getting to that population, the Nature Conservancy put in a big effort, and this is a data set put together by Mike and also Adam Stark at the Nature Conservancy. They've been doing hard clam spawner sanctuaries. They started in 2004, and we're very excited to see in a short period of time, this is the abundance of juvenile clams, a great abundance in 2008. But then, things all of a sudden didn't look very good. And it had them somewhat scratching their head. You know, why would that be, that they'd go from this great set that suddenly disappears, and then maybe something coming back again, and then it suddenly disappearing? Well, if you plot this against brown tide occurrences, it's very clear what's going on. There was a massive brown tide in 2008, and following that brown tide, all the hard clams died. Actually, there was no brown tide really no substantial brown tide between 2008 and 2012. You can see the population began to rebuild. And as I'll talk about momentarily, we're in a different era now in Great South Bay, and the brown tides are happening every year. And so, these brown tides are not going away. They've moved to the South Shore, but they've taken up what I would call permanent residence. Here's the occurrence in the area of Moriches and Shinnecock Bay. You can see they were kind of sporadic. They're now happening every single year. Differing intensities, but they're not going away. And in Great South Bay, as I'm sure many of us are aware, there's the new inlet that formed during Hurricane Sandy, which has had some great benefits. So, for example, in 2013 and 14, comparing the red to the area, which is the middle of Great South Bay, to the inlet, you can see even when we had intense blooms in Great South Bay, the inlet kept the brown tide in check. But still, last year, for the middle of Great South Bay, the brown tide was actually record-setting. We saw cell densities we've never seen before, more than 2.3 million cells per milliliter, and the bloom lasted longer than ever before. It started in early May, and it persisted till late July. These blooms are becoming actually more consistent in Great South Bay. This plots the percentage of years that brown tides occurred in Great South Bay before the new inlet. Here's the percentage of years after. It's 100%. Right? So the new inlet is helping. However, it can't do all the work. And so what this is showing here, just comparing these two, is what we'd call the residence time of the water. The darker the red, the longer the water sitting around in Great South Bay before and after the inlet. And so what you see is this magnificent transformation in the eastern part of Great South Bay. Bellport Bay went from an area that is very stagnant, very prone to algal blooms, to one that is very well flushed. There's that new inlet. And that flushing is not only benefiting Bellport Bay, but it's actually cleaning out this area, Narrow Bay, and also the western part of Moriches Bay. However, if you look very closely and you compare these black boxes, same exact area, the western part of Great South Bay has become more stagnant. And that's the area that's now more prone to brown tides. And so, and without mitigating the nitrogen load, that makes it more prone to more intense brown tides going forward. And I'll just leave this by saying, many times people will say, well, we'll dig a new inlet, we'll dredge, and that'll fix the problem. And it will. But there is the law of unintended consequences, and estuaries are complex. And so here's an example of where a new inlet helped tremendously in one area, and in another area that the data would suggest is really critical for the formation of brown tides, made it just worse enough. Now these brown tides are happening every year. I wish the list ended with brown tides, but rust tides is another issue we need to deal with and consider, particularly here in eastern Long Island. Hey, here's a particularly notorious looking one, I think from 2015, aerial view in the Peconic estuary. We worry about these blooms because we know they're fish killing, ichthyotoxic. And we know that very well here at our marine lab. This is a fish kill that happened. This is quite some time ago in the marine lab, but last summer we had oysters dying off in an emergency situation with the presence of rust tide in our intake system. And of course, there's been also fish kills in pens during these events and in isolated creeks as well. And we did not escape rust tide in 2017. We saw it in the Peconic estuary. And for the first time ever, had a confirmed occurrence out in Long Island Sound. So this is, again, off of Mattituck. I don't want to pick on Mattituck, but just what the data is showing, off of the North Shore now in Long Island Sound. And I want to show a curious event in Shinnecock Bay, the town of Southampton Snapper Derby, right? Couldn't be anything that people feel better about than a Snapper Derby. I bring my son to the Snapper Derby. Great event. You can see hundreds of fish caught. They do it when the snapper are running in late August. But in 2017, this is what the water looked like near that area. And I was there with my son, and I can account there were 5 fish caught in about 4 hours. And this has been proven now over and over. When these rust tides move in, the fish move out, right? If they can. Now, again, if they're enclosed, they die. But if they don't, and many of them can swim out, the larger ones, but don't expect to catch any fish when those are going on. And that's exactly what happened last year. You can see the year after year comparison. We know these events are promoted by nitrogen. A paper we published several years ago that they respond favorably to nitrogen more frequently than other types of algae, regardless of the type of nitrogen compound. But emerging evidence in our lab, and Andrew Griffith, raise your hand, Andrew, just finished his PhD in our lab and did a study of how temperature changes affect these blooms. Here are the temperature trends around the east end of Long Island. I showed this last year, which now showing it again. Summertime temperatures, July, August, September, and how they've changed. And this is a big change. And in doing this work with Andrew and other scientists in our lab, we actually looked at the whole planet, right? We used satellite data literally to break down the planet degree by degree. And it's not all us. We, of course, had collaborators. And what we found is that if you look at planet Earth, and particularly the coastal zones, there are areas that are actually cooling. That exists, right? I should say this is data since, you can see, 1982. And since that time, there are parts of the world's oceans that are cooling. There's parts that are warming. The average increase since 82 is about a degree. But we happen to be here in an area, particularly in summer, that's about 3 to 4 times above the global average. And just the way the cards are falling. And in addition, what you'll note is that since around 2004 or so, things are really taking off. Turns out this rust tide loves a temperature just above 21 degrees, maximum growth rates closer to up here. And so what Andrew did for his dissertation is put together the temperature records with the growth rate of the organism to come up with a map like this. This shows how long the potential bloom season has changed for this rust tide since 1982. And you might note, we're in the bullseye here. And what it shows is that since 1982, we have 40 additional days of a bigger window of opportunity for these rust tides than we did since 1982, all driven by warming. Right? And again, this is an organism we didn't even see until 2004, and now it comes back every single year. And so we're very convinced that beyond nitrogen, the temperature is a big issue here. And there's an important takeaway from this. We're not going to stop temperatures from increasing in our lifetime. Okay? We can control nitrogen loading. And so this, in my mind, is evidence that we need to double down on controlling nitrogen, because if we don't, we'll have both the temperature and the nitrogen driving these sorts of trends. And yeah. All right. Last set of harmful algal blooms, which is in freshwater. So these are toxic cyanobacteria, also known as blue-green algae. We worry about them because these are a human health threat. These compounds, these are gastrointestinal and neurotoxins that we've found in the waters on Long Island. And if you've heard my talks before, I can't help but saying that before they had these official names of microcystin and anatoxin A, in the middle of the 20th century when they were first discovered, they were called fast death factor and very fast death factor. True story. So funny, I gotta say it every time. We worry about these because they are carcinogenic. Particular microcystin is known to be both a tumor promoter and can also, associated with different types of gastrointestinal cancers. And I won't go into all the data, but even beyond cancer, the CDC had this study showing, again, not going to go into all the details, but picked out specifically a region in Florida that my student Ben Kramer had studied that is very prone to blue-green algae blooms, and so are significantly higher incident of liver disease, non-alcoholic liver disease in that area compared to the national average. We also worry about these events because of pets. This study by the CDC showed that there's been hundreds of cases of pet poisonings by blue-green algae in the last century or so. And we've had incidences here on Long Island. We had a dog death in Georgia Capon in 2012. And since that time, we had dogs fall ill both in Mecox Bay and in Fort Pond in Montauk during blue-green algae blooms. And again, I always say if you want to see the real evidence, do a Google News search midsummer and put in dogs and blue-green algae, and you'll see some very sad stories. And beyond dogs, just like we had turtles associated with the PSP event, in Queens last year, there was a death of dozens of turtles, red-eared slider turtles. I'm actually not that familiar with those, but dozens of them expired during a blue-green algae bloom last spring at this lake in Brown Park in Queens. And so for all of these reasons, the EPA now actually has standards, both for drinking water and for recreational water. And the New York State DEC is looking very carefully at all water bodies all across New York State. In fact, I'm excited and happy to say that New York State has a better monitoring program for blue-green algae than any other state in the union. And I can say that emphatically. It's just the fact. And they're doing a great job, and we're actually proud to partner with them. We are responsible for monitoring Long Island and New York City freshwater bodies and reporting on a weekly basis to the DEC between May and November on the occurrence of those events. And I know Jen is here. She's organizing that program for us again starting this May. And for good reason in New York State, because many people in New York State, here in Long Island, thankfully, these blue-green algae blooms are only going to be a recreational threat. But in upstate New York, people are getting their drinking water from, for example, the Great Lakes and the Finger Lakes. It's a very scary event last fall when 7 of the 11 Finger Lakes had blue-green algae blooms. And these are the drinking water supplies to places like Syracuse, Rochester, and for this particular lake, Skinny Atlas Lake, that was the only lake left of the Finger Lakes where the water was essentially delivered untreated. It was so pristine, and obviously that changed, and that led to Governor Cuomo actually initiating what he called the New York State Harmful Algal Bloom Action Plan, specifically actually not focused on Long Island, but focused on upstate lakes where, again, these 12 lakes supply a lot of people their drinking water, and to get to the bottom of this and make sure that New York State residents are protected against these blue-green algae blooms. But if we look all across New York State and think about where blue-green algae blooms are most prevalent, the answer is actually Suffolk County. So once again, in 2017, there were more lakes and ponds with blue-green algae blooms than any other county in New York State. And remember, this is a robust program. They're looking at every one of the 62 counties, and 47 of the counties had some report. But Suffolk County is far ahead of the pack with regards to number of water bodies with these blue-green algae blooms, and also the number of weeks that these are listed. So every time it's listed, it's week after week, so these lakes are staying on the report. And here's the top 10 for all of New York State. And so you can see places like Lake Agawam, Mill Pond and Watermill, Old Town Pond in Southampton, being listed, making the top 10 for the lakes that are most frequently listed in New York State. I referred to Fort Pond before. Some of you may know Fort Pond in Montauk, of course, is Montauk, one of the most important recreational locations on all of the South Fork, a multi-billion-dollar industry, just the recreation of people going out there on vacation. And every September, they have one of many different sporting events there, but the mighty Montauk Triathlon occurs there every September. Of course, a swim, bike, and run until last year, when in September, that water body had a blue-green algae bloom, and they actually had to cancel the swim portion of the triathlon. It became a run, bike, run, because they were unable to swim within Fort Pond Bay because of a bloom of microcystis. And our lab was monitoring very carefully. We worked very closely with them. We monitored almost daily up to the end, hoping that it would go away, but it didn't. And it persisted through the race event. And so, to me, just like the fishing event, this is an unfortunate commentary on what's the fate of some of our water bodies here on the East End. We know these events are promoted by phosphorus, in part. This shows the relationship between the diversity of different types of phytoplankton and how that changes. And when you get to high levels of phosphorus, you have mostly blue-green algae blooms or cyanobacteria. But we also know nitrogen is very important. I published a paper 2 years ago essentially emphasizing that nitrogen, as I pointed out before, promotes toxicity and also promotes these blooms. And this just isn't me, but these are scientists from around the world who all were able to identify different examples from places in Europe and across the United States where this is the case. And the EPA now is promoting the idea of dual nutrient control and dual nutrient criteria, because these events, yes, they can be controlled by phosphorus, but nitrogen also plays an important role. So beyond the harmful algal blooms, we also are looking at just general water quality all across Long Island. And last year, we continued to work with News 12 to bring Thursday night during the weather forecast Bill Corbell, good friend of the lab now, delivers the water quality report to Long Islanders. And so the whole team, I can point to everybody here, is involved. On Mondays, we're fanning out to more than 30 locations, bringing samples back and reporting back by Wednesday for the news by Thursday. But this year, we also had a great advance. Where is Ryan Wallace? There he is. Ryan helped pioneer a new approach. I'm calling it Eyes on the Bays. I don't know what he calls it. But you can see what we put together was a network of continuous monitoring stations all across Long Island. And so for each of these stations, you can see the kind of construction job that gets done. And I see, let's see, we got Craig here as well, who's helped out. Also Andrew Lundstrom, who's not here. But you can see the different devices they put together, solar powered, and continuously recording data. So we have this website that will go live again momentarily, or maybe partly live already. We had, I think, 8 sites last year. We'll have more this year. Where at any point in time, you can go to this site and see things like the temperature, the salinity, the dissolved oxygen, the chlorophyll. And there's also the ability, again, you can pull up in an individual site and look exactly what's going on at one time. We had a site on Robbins Island, for example, for Peconic Bay. But you can also get the data record. So you can then go in, if you can choose the time frame you want to look at it. Look here, it's just a week, but you can look over a month or more. You can download the data. So real-time information to know what's going on in your water body as the summer progresses. But in looking at our overall water quality index, this is what things looked like in 2017. Good water quality, somewhat hard to come by. You can see that, and this is a somewhat consistent trend. We've done this for several years. The Peconics often looking good. The eastern part of the North Shore looking good, and the South Shore often having problems. Because of, and I've talked about this before, such a shallow water body, in many cases only a meter or two deep, and then the whole southern half of the island draining into that, with also slow flushing times when it comes to tides. One of the most important things we're looking at here is oxygen. And for those of you who don't know, the excessive amounts of nitrogen that leads to algal blooms can lead to low oxygen, which of course is harmful to marine life. And the DEC has a standard for oxygen of 3 milligrams per liter. You can see they want about 4.8, but they really don't want excursions not less than 3. So if we look at our continuous monitoring, because we had that beyond the sites that we showed there, we had other sites that weren't on the web, and we're continuously monitoring the oxygen because we know the levels can change between day and night. And I'll just give a quick example of that from the Forge River, which gives a great example. A lot of wiggle here, and this might look like bad data, but this is the natural cycle of oxygen in our bays. High during the day because of photosynthesis, low at night. So the question is, what are the oxygen levels in our bays? For decades, Suffolk County has a great data set, and I'm so grateful we have it. It goes back to 1976. So we really can track what's happening. But they measure oxygen during the day. And so what this is showing you is, tell me what the oxygen level was in the Forge River during this data set. Kind of hard to say. This is what the minimum was. If you decided to go at 7 a.m., it might be there, or 8 a.m., or if you went at 9 a.m. But I actually worked together with a gentleman from the EPA who also looked at this data and looked at the state standards. And he said, well, if you decided to make your measurements at 11 o'clock, which is on average when most people go out in Suffolk County, on average, that's when the measurements are made, you'd say, well, the water body is in compliance 75% of the time. If you went at 8 a.m., you get a different answer. If you use all the data, and again, remember the language, no allowable excursions, it's actually hitting that standard only 3% of the time, or 3% of the days in that particular month. And so when we look at 2017 in oxygen and all the sites that we looked at, 30 some odd sites, we had one that had good oxygen. It made that 4.8. We had a few others that were what we call fair. It didn't make the 4.8, but it didn't go below the 3. But then we got 22 sites where at some point in time they did not make the standard. And then another more than a dozen, a baker's dozen in fact, that actually got to just about 0. And so now the question is, does this matter? Well, this is going on. We're violating the standards. Now we know. Should we care? And so I tasked Mike Dole, and he worked with others in the lab to figure this out. So he set up some very simple experiments last summer. Well, we chose some sites where we knew they'd have good oxygen, fair oxygen, bad oxygen. He deployed some bivalves to see, well, how did they respond? He put out oysters, juvenile and juvenile clams. And, well, here's what he found. It matters. The survival of the oysters could be predicted by 88% of the data could be explained simply by oxygen, a highly significant result. Similarly, their growth rate was also significantly related. You could explain 82% of the data just on the oxygen levels alone. So yes, it does matter. And I'll point out he also had a similar trend for hard clams, although with the number of replicates, so number of samples we had, it wasn't statistically significant as these two were. And I'll point out, as I think some of the posters out there had pointed out, that in addition to low DO, at the same time we're seeing low pH, which is also a physiological stressor on this marine life. Last thing before I talk about how we're going to fix all these problems is that the idea that we really do all have a stake in this. So Dr. Anthony Dvorkis at Stony Brook University had a master's student recently finish his thesis where he looked at the relationship between water clarity and home values. Right? So I just asked you, does it matter that the oxygen levels are low? Does the marine life care? Yes. Now, if your water is not clear, should you care? Well, the answer actually was an astonishing or a resounding yes, particularly if you have a waterfront home. So the study was able to show that 3%, and this is with statistical significance, 3% of home values can be controlled by water clarity. And we know how expensive homes are. If you have a $5 million home, that's a good chunk of change, $150,000. And this is cut off there a little bit, but this effect extended out to 1,000 meters away, right? Which is, getting towards up a half a mile, where still not as big of an effect, but still up to 2% of your home value controlled by water clarity. And the trends were strongest along the South Shore, weakest along the North Shore, which to me made perfect sense because there are strong gradients in water clarity across the South Shore. So we all have something at stake here. So just to wrap up the nitrogen loading aspect, nitrogen loading is intensifying harmful algal blooms and leading to low oxygen. These events are getting more intense over time. They're a threat to marine life, aquatic life, human health, the economy. And as I emphasize, I'll just say again, as climate change accelerates, many of these events will get more intense. For example, we know warmer water on its own will lead to lower nitrogen. So again, making the control of the things we can, like the nitrogen, so important. Okay, so now, if you're thoroughly depressed, we're moving on to the hopeful part of the presentation, and the fact that making a change when it comes to nitrogen load can have positive effects on Long Island. We know this, the data's there, so let me give you the examples. One of my favorites is in Northport. I see James Ammerman here, he lives there, he loves this example as well. The fact that in 2013 they upgraded their sewage treatment plant, and that upgrade was after a coalition came together at the federal, state, county, town, village levels of government, all got together and said, there's a problem, we've got running toxic red tides here, we need to clean up the sewage treatment plant. Because in 2008 we published a study that made the link, 2010 we published a study making the link from the nitrogen loading to the red tides. They got the money, they upgraded the sewage treatment plant. You can see the nitrogen discharge dropped and then dropped again by more than half. And we haven't seen a PSP closure there since. So it went from having them every single year, the biggest closures on all of Long Island, to being an area where, there is the organism there, but it's not getting to the same levels anymore. And like I told you, when you cut back the nitrogen, it becomes not only less intense, but also less toxic. Long Island Sound is another area that's starting to respond to changes in nitrogen loading. There's a target of reducing nitrogen loading by 60%, and that target, Jim, has that target been met? That target's been met. Now again, does it matter? This costs billions of dollars. Let's see, this better matter, right? So well, let's look at the maps. Look at the before and after. We've got large regions of the Long Island Sound that no longer are part of the dead zone. This was the dead zone before, here's the dead zone after. And even the areas in the dead zone, you can see there's a large area that's no longer having that super low level of oxygen. And here it is year by year. If you go from the year 2003 onward, you can see a steady decline this is the square miles with oxygen less than 2 milligrams per liter. And again, coming back to climate change, I'll emphasize the 2 years that really jump above this line were 2012 and 16, which, go ahead and look at the records, were unusually warm years. 2012 record setting in many ways. So this is what the future might look like. So again, if we're not going to be able to change the warming, if we do deal with the nitrogen, we'll make that system more resilient to the occurrence of hypoxia. And then on the South Shore, the Bergen Point Sewage Treatment Plant was put online in 1981. Before that, sewage was being discharged into Great South Bay. With the implementation of the plant, the sewage went offshore out to the ocean. This area here, anywhere you see in blue, is an area that grew new eelgrass between 1979, just before the sewage treatment plant came online, and the survey that was done in 2002, a gain of nearly 3,000 acres. And I can tell you that this is the only time this has ever occurred in the history of Long Island. That is the regrowth of eelgrass. The same survey extended to the western part of Great South Bay. There was a loss of 5,000 acres in the part of eastern Great South Bay where they did not control the nitrogen loading, but where they took the sewage out, regrew 3,000 acres. And there's also signs that if we reduce nitrogen loadings, ecosystems will respond. So for example, in Nassau County on the South Shore, an area known as the Western Bays, currently the Bay Park Sewage Treatment Plant discharges into Reynolds Channel. You can see what that looked like after Hurricane Sandy. And the unfortunate thing about this discharge is instead of it going right out the ocean inlets, it seems to fester within the bay. However, there's now a plan that I think is pretty solid and is going to happen where they're going to reroute that sewage to the Cedar Creek ocean outfall. And so we had done a study to model how might that affect the seagrass. And so what you're looking at here, again, Ryan Wallace had worked on this. This is the map before or current, and looking at whether an area is suitable or unsuitable for seagrass. You can see mostly unsuitable. But with the removal of the sewage there, it opens up nearly 3,000 acres that would then be suitable for the growth of seagrass. Closer to here, within Shinnecock Bay, we've done some modeling that couples nitrogen loading, hydrodynamics, the tidal circulation of the bay, and some food webs. I'm not going to get into the details, but I'll give you the punchline, which is the model works. It predicts accurately the current levels of nitrogen. This is specifically for Quantuck Bay. Predicts accurately the current levels of brown tide, and predicts that as you decrease the nitrogen loads from 100 to 75, 50, 25, and 10% of current, the intensities of the brown tide each year would decrease. And then finally, very close to home here in Southampton, a modeling study done for Lake Agawam that considered what would happen if part of the downtown area was on a sewage treatment plant and another part, the remaining part, were on advanced septic systems, which I'll talk more about momentarily. And essentially what it shows is that just by having a part of the downtown on a sewage treatment plant, you could reduce toxin levels by 50% and have a 75% reduction if you put the rest of the downtown area on these advanced septic systems. Okay, so moving on to what can be done with regards to reducing nitrogen. We live in a very good time for water quality. For those of you who don't know, County Executive Steve Bellone in 2014 declared nitrogen loading public water enemy number one and said that clean water was the top priority of his administration. And and those are some bold claims, and he delivered. He has moved forward with this comprehensive water resources management plan for I don't know how long. At the State of the Bay Symposium, people would raise their hands and would say, when is the county going to allow advanced septic systems that remove more nitrogen? Well, it happened more than a year ago. So you can see in the summer 2016. And so they've moved forward. They have multiple systems that they've approved for installation at homes. They have a standard of 19 milligrams per liter. And you can see all the systems are at or below that level. I think another one here that needs a little bit more testing. But we have some representatives from the Center for Clean Water Technology here. We've got Dr. Stuart Waugh and Molly and Samantha and Caitlin, raise your hands back there, who have been working hard on coming up with solutions for treating wastewater. And at the Center for Clean Water Technology, our goal is 10-10-30. One person once thought it meant that we'd solve the wastewater problem by October 10th, 2030. No, that's not the case. 10-10-30 means we want systems that get nitrogen down below 10 milligrams per liter, systems that cost less than $10,000 each, and that will last at least 30 years. And you'll see we're making good progress on this goal. So the first system I want to talk about is something known as a nitrogen-reducing biofilter that connects to a typical septic tank in a home and has one moving part, a pump. So this is therefore considered a passive system. It runs otherwise on gravity. Low energy pump that simply delivers the wastewater to this filter. That filter looks like this. It uses a drain field, which is the way most of this nation treats on-site wastewater. They don't use these deep rings that we have. Instead, they use a drain field at the surface, which has the advantage of, in season, you can even get vegetative uptake saved by lawns. But these drain fields then deliver goes from the pump tank to the drain fields and slowly is dispersed over 2 layers of sand. One that's just strictly sand and one sand mixed with sawdust. Again, these are, I'll emphasize, passive systems. These are non-proprietary. We're not looking to make money. Conversely, or actually quite the converse, with no patents on these, anyone can install them. And so actually all the money would stay right here in Long Island for people and companies that design and install these systems. Whereas all the other systems are being exported from other companies and other places. And therefore we'll be using all Long Island materials, Long Island sands and wood chips, and Long Island labor. So this will be potentially an economic engine going forward. And just to get into the chemistry, we have those 2 different layers because we have nitrification happening in the sand, converting the ammonium to nitrate. We have denitrification in the layer below that. The wood chips promote that, reducing the oxygen and converting the nitrate into nitrogen gas. And so we have a few different systems. One system we have, again, those 2 layers, some people call these layer cake systems. We have one that's lined, has a plastic liner around it. This one and 2 more I'm about to show you have been testing for more than a year. And so here's some data. There's a test facility in Massachusetts where we got permission to build and install these with Long Island sand, Long Island wood chips. And here's the performance. Total amount of nitrogen coming in, total amount of nitrogen coming out. And you can see what the data shows. Firstly, what you'll see, and I'm going to show you 2 more of these, there's seasonality. In the summer, when the temperatures are warmer, the microbes move quicker, the ambient oxygen levels are lower, and so denitrification is more efficient. So this is summer. Winter, with higher temperatures, things are less efficient. But the exciting thing is that on average, over more than a year, we're down below 8 milligrams per liter. Remember the standard's 19. And in some cases, we're very far below that. And almost never even above what the average is supposed to be, which is the 19. Now another system we've tried has no liner whatsoever. Simpler, maybe a little bit less assurance that this system will have, the lower layer will have no oxygen, but performing very well also. So again, in this one, same data set, average concentration or effluent 8.5 milligrams per liter. And the last system is a little bit greater leap and iteration in that it has the sand layer that then goes to a septic tank that's filled with wood chips. And so with this particular system, it's the best performer of them all. And again, you can see over more than a year of data, 3.2 milligrams per liter, and over the summer, very, very low levels. So we're very encouraged by these data, and it's exciting to report that we've begun to install these on Long Island. So we had our first 3 systems installed this spring at a press conference last week. Was it last week? Week before last week. For the installation with great support from Senator Ken LaValle and Assemblyman Fred Thiel, and Peter Scully from the county was there also. It was a great event, and it's exciting to see these. All 3 of these systems are now officially in what are called the pilot phase for Suffolk County. So we'll have 3 of these systems in for each type, and once they're in and performing for 1 year, we get 1 year of data on these pilot systems, they'll then be provisionally approved for more widespread installation. Beyond our nitrogen-reducing biofilters, Samantha's doing her PhD specifically looking at constructed wetlands. This is her slide. And they have lots of advantages. Also, passive systems can look beautiful in some cases. You can design them as you like. and work on removing more than just nitrogen but other contaminants. And I should mention, I forgot to mention, but I'm going to mention now, just to toggle back to these systems, they remove more than 90% of 30 different organic compounds we tested for, including pharmaceuticals, drugs, personal care products, DEET, nicotine, other sorts of contaminants, which is better than a sewage treatment plant. So it's not just nitrogen, they're removing other contaminants as well. And this slide reminded me of that important fact. But on the wetlands front, Samantha's made good progress. She's installed and worked collaboratively with the county, where we've installed the system on Shelter Island at Sylvester Manor. It's called the Recirculating Gravity Filter System that has plantings on the top, gravel filter system. Gravel below that, the water is recirculated through, and in the end, achieving low levels of effluent nitrogen, 8 to 16 milligrams per liter, which is great. She's also done some test plantings up in Massachusetts, the same place we had the other facility. And in those, she's testing different plants, different densities, and having good results with her mesocosms, not quite as good as the nitrogen-reducing biofilters for these. Again, here hovering all around 20 or so. However, beyond her mesocosms, she also experimented with having what we call a polishing step. Again, using the magic of wood chips or even mulch, so delivering from these systems, then going into a mulch or wood chip filter. And these are the actual concentrations of nitrogen coming out of there. And you can see 0.16, that's not a decimal place error, that's real. And you can see the numbers, 99.6 and 99.8% removal. So these wood chips are quite powerful. I don't claim that we'll get this every single time, but what this shows is the great promise in this sort of approach and technology. And as we do this, I want to point out that once we make these changes, we can see our waterways change in a very quick amount of time. So again, Suffolk County is doing something they call their sub-watershed studies, looking at the travel times of groundwater all across Long Island. But here on the North and South Fork of Long Island, we are incredibly lucky because the groundwater travel times are so short. So for example, on the North Fork, after 2 years, 66% of the groundwater has flushed out, which means if you change everything now, in 2 years' time, you're going to see that difference. And in 10 years, it's 84% of the groundwater having flushed out. And on the South Fork, it's not quite the same, but again, at 10 years, 74% of the groundwater has moved out through the aquifer, which means that some people have said, and it's true in some places, it's taken us decades to get into this mess, it's going to take us decades to get out, right? And that is the case maybe for some parts of Long Island, in that there are some areas where the travel times are literally 1,000 years, believe it or not, right? But here on the forks, that is not the case. And you can see there are areas, 100-year travel time. That's a real number, 100 to 200 years. But thankfully, it's only 1% of the whole South Fork. And so, let's focus on the fact that in 10 years, you can have 75% of the nitrogen flushed out. Meaning that changes you make today could be realized in our waterways in that amount of time. Okay, and there's a final thing I'm going to talk about are some additional approaches we're using that can be done now to address nitrogen already in the water. I'm going to start with talking about macroalgae or seaweeds. Some people call these, I saw Craig Shanone there use the word sponge to talk about macroalgae as they suck up the nutrients. One problem is if they grow too much and then they die, then they can actually be detrimental to the ecosystem. Right? They die off, they take up oxygen, and then that could be a big problem. But they can be looked at in another way as well. So for example, firstly, some of us know, but now we will all know, that half of the seafood, or more than half of the seafood eaten on this planet is now coming from aquacultured sources. If you did not know that, now you know it. In addition, one of the big targets for aquaculture, at least in Southeast Asia, is seaweeds, actually. And you can see here, these are seaweed farms, in many cases, going on for miles and miles. Maybe you see the Chinese flag on that boat. It's a little small. And we've begun to explore this here. This is a dock that Craig Young had constructed last spring, within which we have ropes where we're growing macroalgae. And if you look at how it's constructed, this could go anywhere. I mean, think about the number of marinas that we have all across Long Island and people's own dock space. You could put a boat there, and in between are these ropes. And what Craig did last summer is perfect the growth of macroalgae on these ropes and got to the point where by the end of the summer, he was removing a good amount of nitrogen, about 1 pound of nitrogen per rope per week. And again, these are approaches that we're perfecting. Beyond the aquaculture of macroalgae, there's also the fortuitous harvest of macroalgae. And we've learned this very well through the Shinnecock Bay Restoration Program. If you can't see it, here's a net that has been trawled through the bottom of Shinnecock Bay, and if you can see the effort being put in there, that's a few trawls can yield literally hundreds of pounds of macroalgae that contain a lot of nitrogen and phosphorus. And so this shows where those trawls have been done since 2011, and anywhere you see any yellow or green is an area with a lot of macroalgae. And so we've done some, and particularly these sorts of areas in the eastern part of Shinnecock Bay that's very well tidally flushed. So we've done some calculations to determine, well, what would it take to take out all the nitrogen coming from fertilizer, specifically to Shinnecock Bay? And so with some trawling every day or trawling in those specific areas during the in-season, you could possibly take out more than 50% of the fertilizer-based nitrogen for Shinnecock Bay. And similarly, if we had many of those docks, you can take out all of the nitrogen. Again, it's just a matter of scale. And when it comes to aquaculture, Mike Dole would tell you, he was in aquaculture for a decade, it's all about scale. And big scale can lead to big results. We've actually done harvesting in other locations. So for example, in Georgia Pond, which had a big problem with macroalgae in 2014 and 2015. And following that, with the collaboration with the Friends of Georgia Pond, we initiated a program whereby, with permits from the New York State DEC, we used an aquatic weed harvester to go in and remove the surface macroalgae. And so this is a sort of a modified, in New York City they have things called garbage barges that just collect floating garbage, and that's partly what this also does. It also goes down slightly below the surface and will cut any macroalgae that are growing off the bottom, growing from the bottom, but leaving everything there on the bottom. And again, like I asked before the auction, does it matter? So last year, the harvest from Georgia Pond was almost 33,000 pounds of macroalgae. And this is a semi-dry weight, and it's not a fully wet weight. The year before, it was even greater. However, in doing calculations, it's only a small part of the total nitrogen and phosphorus load, somewhere between 1 to 2% for the whole year. In summer, it could be somewhere between 6 to 20% of the nitrogen and phosphorus load, which again doesn't seem like it would be that important. But one interesting thing is that the system was very different in the years when we did this. So we had this is showing data Mark Lusty helped put together, looking at the growth of blue-green algae within Georgia Pond, a massive bloom that occurred in 2015, very similar event in 2014. With the harvester in place, however, we had no blue-green algae bloom for the last 2 years. And in addition, during 14 and 15, with the blue-green algae blooms, at night we had anoxia. So the water oxygen level is going to 0. In the interest of time, I'm not going to show all that data, but I'll tell you we didn't have summer hypoxia in these 2 years as well. So we need more data, but it's certainly not making the ecosystem any worse, and we're removing a lot of nitrogen. And so just to show what we think may be happening when we don't remove that nitrogen, the sequence of events that macroalgae, the sequence of events that the macroalgae would collapse, and immediately following that is when we got the blue-green algae blooms in 2014 and 2015. So the working hypothesis is that their blue-green algae are growing off of the macroalgae, whereas with the harvester in place, we're removing the macroalgae and perhaps depriving the blue-green algae of those nutrients. The question is, what do you do with all that macroalgae? So we know in the past that fertilizer, in addition to wastewater, is part of the problem. It's not the biggest problem. I told you it is wastewater. But fertilizer certainly is part of the problem as well. And the relative importance depends on where you are. And remember, any fertilizer that's used on Long Island, just have this vision. Every spring, there are tractor trailers full of fertilizer driving onto Long Island, and it's all getting deposited. And that happens every single year. And we see how our ecosystems have responded. So I am posing the question and challenging our lab group to try to figure out, what if we close that loop? And instead of having those trucks come on, what if we were taking that macroalgae and turning it into fertilizer, which could then be reused? What would be the response then? And so we have a few different approaches we're trying, making liquid fertilizers, composted fertilizers, comparing the results to Miracle-Gro potting soil or native sandy soils. With our liquid fertilizer, we're able to leach lots of nitrogen and phosphorus out of the macroalgae into solution, so we know we're making a potent solution for a fertilizer. And to show some results, this is growing marigolds, which has become Craig Shannon's favorite plant to grow with this fertilizer. And so here's our positive and negative control, and that you can see the potting soil does much better with regard to growth rate and the weight of the plants. But when we supplement that same exact soil that we're using for the negative control, and we put in some of the dried macroalgae or our liquid macroalgae, you can see we're getting more rapid growth rates and also heavier plants overall. And so, in some cases, even more so than the potting soil. And this is going from seed, I should emphasize, to a flowering plant. So I think we're onto something. And then just for a fun result, I had another student, he's not here tonight, Chris Wozny, who last summer said, I know a guy. I know a guy who has a nursery, and he's got a bunch of habanero pepper plants that he can give you for some experiments. I said, okay, we'll try it. So we tried it, and we had an interesting result in that when it came to the weight of the peppers, we had achieved a weight with the dried ulva that was just as good as with the potting soil. So there's a lot of work to be done, but just evidence that this source of this macroalgae can be removed, not just can be removed from ecosystems, not just to mitigate nitrogen and phosphorus, but then to become something used sustainably. And then the very last thing I'm going to talk about is bivalves and shellfish and the Shinnecock Bay Restoration Program. And so, wonder if this is going to work. Don't know if it's going to work. Let's just see. It looks positive. And most of you know this probably, but I'll just show it anyway. And so this shows the awesome power of clams. Tank with algae, very dense. Tank with clams, you can see the clock going. And this is something we've seen year by year. Most of us know this, that clams and oysters do a spectacular job of filtering the water. But we also know that the densities of clams and oysters are down, in some cases, landings down 99%. The landings in Great Salt Bay are down 99%. For hard clams, they're down more than 90% for bay scallops. So knowing what they can do, we've been motivated to try to bring these populations back. And so since 2012, we've put in more than 60 what we call spawner sanctuaries in Shinnecock Bay. These are a great collaborative effort on multiple fronts. Firstly, these are DEC approved, one, each spawner sanctuary. These sanctuary sites came together because the Baymen agreed to do this, and the Southampton Town trustees agreed to make these regions. And so with areas that are no-take zones, we're planting densities of hard clams significantly greater than what we had before, because we knew when we started this program, the clams were more than a meter apart, there's less than one clam per square meter. And we knew at that density, these broadcast spawning clams would not be able to successfully reproduce. So we're reversing that here by planting 20 clams per square meter instead. So when they spawn, and I won't get into the biological details, but I'll just, with the hand motions, when they spawn their gametes into the water, the chance of successful fertilization, collision, is much higher than if they're spread far apart. And with specifically an incredible effort last fall when Mike Dole came on the scene, we are now at more than 3 million adult hard clams being planted. And again, these are adults. So we're not going for little juveniles. We're spending the money and putting in the effort and using the manpower to put in full-on adults that we know will be able to reproduce and survive better than juveniles. And we're starting to see results. So these are the densities of juvenile hard clams. Dr. Brad Peterson's group did this surveying, and what you can see is after a slow start in the last few years, juvenile hard clam abundances are increasing across Shinnecock Bay. And they're specifically showing up in areas where our hydrodynamic models say they should be at high densities. In addition, we see that since 2014, we're seeing larger clams grow up and get more abundant, and we're seeing the landings of hard clams in Shinnecock Bay take off. A 400 to 500% increase in the landings of hard clams in Shinnecock Bay. And so this is somewhat unprecedented in that Mike got the records going all the way back to 1987. We're at almost a 30-year, or we are at a 30-year high in hard clam landings in Shinnecock Bay in 2017, which is remarkable. And we think is at least in part due to the clams that are being produced by our spawner sanctuaries. And to the point where now the landings in Shinnecock Bay are almost the same, or are the same, as they are in Great South Bay, which is 1/10 the size. I'll say that again. The landings in Shinnecock Bay are now about equal to Great South Bay, 1/10 the size. And so that is, I think, spectacular. And we're starting to see other parts of the ecosystem respond as well. The last effort I'll talk about by the Shinnecock Bay Restoration Program was the creation and installation of the first permitted man-made oyster reef on Long Island, in fact. So this is an aerial view, if you can't see it. These are shell bags, each individual shell bag being a few feet apart in length. Well, I'll show some details. But all in all, 600,000 oysters put on this outline of this reef. This is empty in the middle right now. It's going to be filled in with shell and then topped off with live oysters in the coming months. And so the process is we're leading up an effort that was started by Andrew Griffith and continued on by Mike Dole and many other people participating, whereby we're setting spat on shell. Adult oysters are spawning, growing up in conical tubes. We have a cohort going right now that we then set on shell. And then these are the shell bags that go out. In some cases, they're little tiny spat on shell. In some other cases, the oysters, after a couple of years, obviously quite large. And that's what goes on the top of this oyster reef. And here are the people in the lab, like Tim Curtin and Peter Silvers and others, putting out these shell bags. I think it was actually early December when this went out. And so, but hardy souls, these folks, and they got it done. And there it is. It's right as you go towards the Quad Canal in western Shinnecock Bay. And we have permits to put in 3 more of these in Shinnecock Bay as well. And these are going to be a great tool for studying, how does this work for restoring oysters and creating habitat. And the very last thing I'm going to talk about comes back to almost 1 year ago. I mentioned how bad the brown tide was last year, and I put out a press release last May that talked about how bad that was. And a week later, my phone rang. And it turns out it was Governor Cuomo's office, and they asked me a whole bunch of questions about brown tide. And then moments later, my phone rang again. And I fumbled with my phone. I was driving at the time. And it turns out it was the governor himself. And he specifically said to me, I just passed a bill for $2.5 billion for clean water infrastructure, because I care about water and I want to clean up New York's waterways. However, I know there's a brown tide going on now, and I know that changes we make today may not be realized for several years. He said, what is it we can do right now to improve water quality when we don't have to wait? And it was like a pop quiz, of course, because I didn't know he was going to call. And the first thing I thought of was the success we were having in Shinnecock Bay. So I explained to him the Shinnecock Bay Restoration Program, what we were doing, and I said, you should come out and see what we're doing. And sure enough, as I said in my intro, 2 days later, Governor Cuomo came out. We took him out on the boat. We deployed some clams. And I'll just be perfectly honest, I was incredibly impressed by this man at many levels. On the boat, there were many politicians. There was a whole camera crew, and I figured it would be a press event. But instead, the governor, the entire time, he spent the first half of the time in the boat just firing questions at me, point blank. Scientific questions. Why are you doing this? Why clams? What about oysters? And why are you doing that? What else can we do? What about hatcheries? He kept asking me questions all throughout. And when he was done asking me questions, he then turned to the politicians, and instead of just having mindless banter, he was actually talking about, what can we do to bring back shellfish? What about building hatcheries? And so that's how the rest of his conversation went. We then pulled up to the Marine Lab. You can see this is right here, there, where he gave a speech. He got off the boat. He walked off. He had one Post-it note. Right? And what I learned is that Post-it note had the names of a few important people who were politicians he was supposed to mention in the audience. He then put it down and he gave his whole speech without, no notes. And what was incredibly impressive, one, he reiterated all the science I had fed him just a half an hour ago. So he wasn't just asking questions for the heck of it. He was listening and he understood it and he fed it back. And I was very impressed by his environmental ethic, because he really believes that taking care of the environment is his responsibility and every citizen's responsibility. I thought that was the end of my interaction with the governor. Turns out it wasn't. And the week later, I heard from him again, and the week after that. And I spent the summer working with his staff, coming together and talking about what eventually became, if you can read the text there, the Long Island Shellfish Restoration Project, which is a plan put together that is now collaborative with multiple organizations to essentially do the things that we've done in Shinnecock Bay and to put those in multiple locations. So we've got 5 different sanctuary locations beyond Shinnecock Bay: Bellport Bay, South Oyster Bay, Hempstead Bay, Huntington Harbor. And we've got multiple organizations. Cornell Cooperative Extension is leading the production of juvenile clams and juvenile oysters. It's going to be an enormous effort, an unprecedented effort. And then Stony Brook is working with them and the DEC for putting out adult shellfish. And then also the Billion Oyster Project is the 3rd member of what is now the Shellfish Restoration Council. And I'll end now with quotes that the governor uses in his speech, that we did not inherit the earth from our parents, but we were borrowing it from our children, which of course we've all heard of, but it's exciting to hear it when the governor says it. And then finally, again, stealing one of his slides, it's up to us to leave our world better, safer, and healthier than we found it. So with that, I will end. The major points being that the mishandling of land and pollutants on land is contaminating our groundwater. The excessive nitrogen from that groundwater is an ongoing threat to coastal ecosystems, economies, pets, and human health. Nitrogen reductions have already been shown to lead to significant improvements in different parts of Long Island, and we'll continue to need both the watershed-based efforts and the in-water efforts to help restore Long Island's coastal waters. So with that, I'll thank you very much for your attention. And I just looked at my watch for the first time. I do apologize. I did not want to go that long, but I'm sorry. So I'd be happy to, firstly, if anybody has to leave, by all means. Secondly, the students will be at their posters. And thirdly, I'd be happy to take questions. If you do have a question, I'm going to just ask if you can try to ask that question in a single sentence or just 2 sentences so that I can speak to as many people as possible. Yes, sir.
You mentioned PSP and ribbed mussels.
Yes.
Are hardshell clams, squahogs, and steamers in the same creeks at equal risk?
Yes. The one thing I would say, though, is that mussels tend to take up more of that toxin than other shellfish. And so, for example, when the New York State DEC monitors for PSP, they put out blue mussels as what they call their indicator organism, because they tend to take up more of the toxin than other shellfish. But the toxins do show up in other shellfish as well, and that's why when there's a closure, it's for all shellfish. Yes, Ron.
Dr. Gobler, what is the expected lifespan of some of the alternate septic systems that are being put in place?
That's a good question, and just being perfectly honest, we don't know exactly. And I showed you our goal. Our goal is for a 30-year life expectancy for our systems. Our systems mainly run on a pump and wood chips, and the wood chips, we believe we've done calculations that would suggest that they should last 4 decades. But the one thing to recognize is that all of these systems, when you change your septic system, you have to go through the Suffolk County Department of Health. They're in charge of sanitation, household sanitation for all homes. And I believe that with the installation of these alternative systems, they're trying to make sure that everyone has a service contract, so that they're being inspected once a year to ensure that they continue to perform. But you know, we need to know more about how long these systems are going to last. There are some wood chip-based systems that have been designed originally, say up in Canada, that have been in existence for several decades, and they're still going. And again, we can theoretically calculate, but we don't have the 100% fail-safe answer. Yes, sir.
You mentioned that the nitrogen loading is an ongoing coastal threat. You also mentioned that the water retention time in Suffolk County is on the order of 2 years. So if the nitrogen loading is increasing over the years, but the retention time is static at 2 years for 75%, is the remaining 25% the additional load that's continuing to cause the nitrogen effect?
Well, until we change land use practices and handling wastewater and fertilizer, even though 75% moves out in 2 years, you know, that we're not seeing any change in the groundwater nitrogen levels. If you understand what I'm saying, then yeah. And so my point was that if and when, say, we change all the septic systems, then in 2 years you should expect a significant decline because you've dealt with nitrogen being discharged to surface waters, because we've dealt with 75% of the groundwater that goes out. We can talk more if you have more questions. Keith.
The wood chips, is there a difference between softwoods and hardwoods? And if softwoods work, could we use the hundreds of thousands of pitch pines they're cutting down to beetles?
So in good news, it looks like there's some research out there. It looks like the type of wood chip doesn't necessarily matter. And so yes, that would be a perfect candidate. And you know, certainly if and when these systems become more widespread, we'll need to have a consistent, reliable source of wood chips to be put into these systems. Yes.
So, as just average citizens, not brilliant scientists like yourself, are there things that we can do to test the PSP toxicity of our waters or prevent brown tide living on the waters in the area?
So, I mean, in very good news, the New York State DEC's Marine Bureau is monitoring for PSP in shellfish. And so I showed you the examples of closures, and that's because they have a very good program. No one's ever gotten sick from Long Island from PSP, and so when they see a problem, they're handling it. And there's good communication between Suffolk County and the DEC and my lab, where if we see a problem, we're sharing information. Once a week, Craig Young is sending out an email, for example, telling the county and the DEC, this is what we're seeing. And that's so people like yourself don't have to test, and that you're being protected by the good work of the DEC. In monitoring. Yes, Steve.
Back to wood chips for a second.
Sure.
Do you have data on the performance of the permeable reactive barrier in Georgia Pond?
Well, there's currently not a permeable barrier on Georgia Pond, to my knowledge. Although we've explored that idea, we're getting some data on that front. You could talk to Molly Graffam. Afterwards, she could tell you about some of the efforts that she's done on permeable barriers in collaboration with Ron Paulson and other people from Cornell. Yes?
For the Mecox Bay case, with the removal of the plants, or is that Georgia Pond? You chose to emphasize fertilizer as a nitrogen source. I'm just wondering why fertilizer and not the on-site wastewater systems of the homes in that area were chosen.
You mean for how the macroalgae removal compares to fertilizer?
I thought the factor driving the macroalgae growth was blamed on fertilizer in that case, or did I misinterpret?
No, I was just giving the example because the concept is maybe eventually that these macroalgae could be used for fertilizer. I was essentially just trying to give a sense of scale. How much would you need to be collecting to essentially be mitigating or making up all the fertilizer that's being used. So, but for sure, your intuition and what you said is that, and again, I'll emphasize, wastewater is the biggest source of nitrogen. But in some cases, fertilizer comes in as second and can be close to half, in some cases. And it's certainly contributing in all cases. So. Yes?
I may have missed this. Why clams and not oysters is a lower filtration rate, and what are the other sites that the clams will be populating?
So for the Shinnecock Bay Restoration Program, we are targeting both clams and oysters, and also for the Governor's Long Island Shellfish Restoration Program, it will be clams and oysters as well. There's a bigger emphasis on clams, largely because both populations are native, but hard clams in recent past have been the most successful bivalve population, more successful than oysters. There's a lot of aquacultured oysters out there, but not a lot of wild oyster populations. So the oysters are we're doing work on oysters, but there's more unknowns and more uncertainty because there's not a native population. And so, for example, what we're hoping some of the restored bivalves will actually be reproducing with the wild populations. You wouldn't necessarily get that with oysters. So working on both, but because of the greater abundance of the hard clams, that's why we're putting more of an emphasis on that.
Can you just quickly state the sites again?
Yes, Shinnecock Bay, Bellport Bay, South Oyster Bay, Hempstead Bay on the south shore, and Huntington Harbor on the north shore.
So that's the longevity end of it. What's the filtration comparison? Are they look the same?
Per individual, oysters actually filter more water. And that's why they're worth not, exploring, not giving up on, and looking to restore. That's partly the motivation for that reef. I'll also say that we found that oysters are more resistant to brown tide and more resistant to high temperatures than hard clams are. And so in Shinnecock Bay, I didn't say this, but I'll say now, we're targeting the oysters in the far western part of the bay, where we know the brown tide is more intense and we know the temperatures get higher. Because our preliminary data suggests that the oysters should be able to, we know, do better there than hard clams. Bill.
Chris, it seems that in your presentation this year there are a lot more bad things than there are good. It seems like there are more different types of toxins. You show them places in your maps that you've never shown before in the past couple of years. My question is the bad outpacing the good? I mean, it's just getting out of hand. People can't drink water that we live here.
Yeah, I mean, certainly on the drinking water front, there's some scary things emerging. And certainly on the general water quality front, there is a case to be made that in some cases things are getting worse, but there also are signs of hope. Like I said, in Shinnecock Bay, the hard clam population reaching historical levels. Concurrently, eelgrass is starting to grow in areas where we haven't seen it in a long time either. So it's a mixed bag, but what is clear is that in the regions where nothing's being done, things are not getting better, and vice versa. Okay, well, I'll thank everyone for coming and say good night. So thank you. If anybody, the students will be back at their posters, so if you have the energy and you wanted to ask a few more questions, by all means. Thank you for coming, and good night.